Hey everyone, welcome back. Let's imagine for a second we're looking at Earth from space. Like those amazing images we get from astronauts. You see those vibrant blues and greens, the continents. But there's this thing down near the South Pole, this massive hole in the atmosphere. That's the ozone hole we're diving into today. Specifically, we're going to unpack some pretty wild findings about 2023.
Yeah, it's a pretty fascinating story unfolding up there in the stratosphere. We've got some excerpts from South Pole's ozone hole, and, well, it really lays out the situation, doesn't pull any punches.
So no sugarcoating. Let's get right to it. How bad was 2023? Because, and I'm not going to lie, hearing the ozone hole described as North America-sized is kind of freaking me out.
Well, you're not wrong to be concerned. 26 million square kilometers, that's the size we're talking about.
Yeah.
The 12th largest single-day area recorded, and they started keeping track with satellites back in 1979,
So yeah, it's huge. Definitely not a small thing then. And this report, it's saying this isn't just a one-off, right? Like there's a bigger pattern here.
Unfortunately, yes. We've been seeing this trend, these increasingly large ozone holes, over recent years. 5 out of the last 8 years, they've set new records for ozone depletion. It's definitely worrying.
Okay, so we're losing ozone, which bad. Pretty sure they drilled that into us back in school. But there was something in the report about a volcano playing a role in 2023. Now that's a new one.
You're talking about the Hunga Tonga-Hunga Ha'apai eruption, early 2022. Incredible images from that, even from space. Might seem totally unrelated, but, well, what goes up in the atmosphere, even from a volcano thousands of miles away, there can be ripple effects.
Okay, so walk us through this. How does a volcano in the Pacific Ocean, no less, mess with the ozone layer all the way down in Antarctica?
It all comes down to the chemistry happening way up high in the stratosphere. That's the atmospheric layer above where we are now. And that eruption, it shot this massive amount of water vapor up there. Now, water vapor itself doesn't directly destroy ozone, but
it can create conditions that make the destruction worse.
Exactly. It's like setting the stage for a bigger problem.
Okay, I'm intrigued, but I need more details. This sounds like a recipe for disaster.
Well, high above Antarctica in the stratosphere, it gets incredibly cold, like unbelievably cold. And when it gets that cold, something called polar stratospheric clouds can form.
Polar stratospheric clouds. What are those?
They're not your typical fluffy white clouds you see on a sunny day. They form much higher up, and they're made up of different stuff.
Oh, okay. So we're talking super high altitude, super cold clouds. And these things are bad news for the ozone layer.
You could say that. See, these polar stratospheric clouds, they basically give a platform for chemical reactions that can destroy ozone molecules. And you know what one of the key ingredients for those clouds is?
Water vapor from that volcanic eruption.
Bingo. It's like someone cranked up the dial on a process that was already happening, pushing the ozone hole to that record-breaking size.
Okay, wow. So it all ties together. Volcano erupts, water vapor shoots up, makes those clouds worse, ozone takes a hit. But the report did mention something about, like, counteracting forces at play, too. Anything good to report there? I need some hope here.
Oh, there's always hope. It's not all doom and gloom.
Yeah.
So yeah, the volcano was a big factor in 2023, no doubt. But the thing is, the atmosphere is dynamic. It's always changing, always in motion.
Right.
And the report pointed out some really interesting stuff about stratospheric weather patterns. It seems during that same period, there were some patterns that actually helped to mix in air that had, higher ozone concentrations.
So there's like a giant balancing act. The atmosphere trying to even things out.
Yeah, exactly. It's incredibly complex, the way these systems interact. We're still figuring a lot of it out, to be honest.
Okay, well, I'm not going to lie. All this talk of record-breaking ozone holes has got me a little freaked out. So, real talk, is the ozone layer doomed? Are we all going to be living under UV-resistant domes in the future?
I get that question a lot, actually. It's understandable. But here's the good news. There's this thing called the Montreal Protocol. It's a global agreement signed back in '87 to phase out those ozone-depleting substances.
Ozone-depleting? You mean like the chemicals and aerosols? And
exactly, like refrigerants, certain kinds of foams, fire extinguishers, that kind of thing. And the good news is it's working. We're seeing those harmful substances decrease in the atmosphere.
Wow, that's amazing. So there's hope. We can actually reverse the damage.
We're definitely moving in the right direction. But here's the catch. The ozone layer, it's slow to heal. Scientists are saying it won't fully recover until, like, the 2060s, maybe even later.
Wow. Decades. That's a long time. But still, it's encouraging to know we have a plan, a roadmap to success.
Right.
And it shows what we can do when we work together globally.
No question. The Montreal Protocol, it's a beacon of hope, a prime example of what we can achieve through global cooperation, through understanding the science. But it also highlights something else, something really important.
What's that?
We've got to stay vigilant. This isn't a set it and forget it situation. We need ongoing research, sustainable practices. We can't let up now.
So we're on the mend, but it's a long process. What does all this mean for us in the meantime? Should I be investing in, I don't know, SPF 1000 sunscreen, lead-lined hats?
Well, the good news is we've already taken some major steps. The Montreal Protocol, that's proof. We're on the road to recovery. But here's the thing. It highlights something crucial.
What's that?
What happens in the atmosphere, even way down in Antarctica, it affects us all.
Because of that ozone layer, it's not just hanging out over the South Pole.
Right.
It's all connected. Just like those weather patterns we were talking about.
Precisely. It's a global system. And that's why that Montreal Protocol, it's such a big deal. It wasn't just about patching a hole. It was about recognizing, hey, we're all in this together. We've got to protect the planet.
It's a good example of what we can do when we put our minds to it.
Yeah.
When we work together.
No, absolutely. A real beacon of hope. It shows, when we understand the science, when we take action, and when we do it together, we can make a real difference. And that's a message we could all use a little more of these days, I think.
Couldn't agree more. So as we wrap up here, for folks listening, probably feeling a mix of whoa, that's scary, but also, okay, there's hope. What's the biggest takeaway from our ozone deep dive?
Well, I think it reminds us, really drives home the point, that we're on this incredible, complex, but ultimately fragile planet. And what we do, even things that seem small, they can have these huge ripple effects. But the good news is we also have the power to fix these problems.
We just have to choose to do it, right?
Exactly. When we work together, when we prioritize the long term, solutions are within reach.
So celebrate the victories, like that Montreal Protocol. But stay aware, stay engaged, because there's always more to learn, more to do.
Couldn't have said it better myself.
Well, on that note, we'll wrap up this deep dive into the South Pole's ozone hole. Thanks to everyone for joining us. If a single volcano can throw our atmosphere out of whack, just imagine the possibilities, for better or for worse, that our actions hold. Something to think about. Until next time, stay curious.